In this video, we're looking at related rates. A ladder 25 feet long is leaning against a wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top moving down the wall when the base of the ladder is 7 feet from the wall? The rate. So let us draw a diagram first. So with this diagram, it's a ladder leaning against a house. So basically, we have a right triangle where our horizontal distance, we could classify it as x. The vertical distance, we could call it y. And the ladder itself, which is this, I could call this the ladder. Then this could be my z. Now we're looking at a right triangle. So the Pythagorean theorem there could help us. Now let's write down some stuff that we know. We do know that the ladder is being pulled away from the wall at a rate of 2 feet per second. That means it's pulling in that way at that rate. So it's dx. So what we have is dx dt, which is equal to 2 feet per second. We could just write 2. We want to know what is how fast it's coming down the wall. So that's dy dt. We want to know this so we don't have this. And we want to know it when x is at 7. We know those things. So one thing with these type of questions is that we have to find the derivative of whatever we're doing before we go. So we're going to have to make some relationship here. So let's relate the idea. Since it's the Pythagorean theorem, then we could say that x squared plus y squared will give us z squared. Now, we could take the derivative with respect to t for all of these. So x squared will be 2x dx dt. Y squared will be 2y dy dt. And this is equal to 2z dz dt. Now, because the ladder is a constant length, it simply means then that the dz dt, this part will actually be a constant. So we're going to actually have a 0 there. So let us rewrite what we got. So basically we have 2x dx dt plus 2y dy dt, and this is equal to 0. We would love to substitute now, but there is only one thing, because I do have 7 to go where x is. I do have 2 to go where dx dt is, but what I don't have is a y value. So what I'm going to do is to take the time out to find y when x is 7 first. So let us go back to our triangle. So here is our right triangle. At this time, we want to assess the value of y. Remember, y is along here, x is along here. So when x is 7, we want to know what our y value is, because this is a right triangle, but the ladder will still be 25 feet long. What are we saying? We're suggesting here that we can easily say y is equal to 25 square minus 7 square. This is going to give me 625 minus 49, and this is 576. So y is equal to, taking the square root of 576, so y is going to give me 24. So now I know that y is equal to 24. Then I'm now able to substitute and then solve for main idea, dy dt. Let us do that. So basically, I have 2 for x. I'm going to substitute 7. And then dx dt is actually 2 plus 2 times 24. And this is dy dt. And this is equal to 0. So what I have, 28 plus 48 dy dt, and this is equal to 0. So basically, we're working through ordinarily. So I'm going to subtract. So I'm going to subtract 28 from both sides. So I do have 48 dy dt, and this is equal to negative 28. Then I'm going to divide both sides by 48. So dy dt is equal to, and we divide this by 4, we get a 7 there, we get a 12. So we have negative 7/12. All right. So what does this really mean? Okay. So the negative is actually telling us that this is actually coming down the wall like this because the distance, because it's falling, right? So it is decreasing here. This vertical height here is actually decreasing. That the ladder is actually coming down the wall at a rate of negative 7/12 feet per second. There it is. See you next time. Thank you for watching DellyMaths Concepts.